Hello my dear students, welcome to Learning Chemistry is Easy and Fun. The topic that we are going to take up today is stoichiometry. Metry is measurement and stoichio means the relative amount of each element or compound which is required according to a balanced chemical equation. That is what we are going to measure. Now, some students find it very intimidating. Some students really get scared looking at the bigger equations. So, what we are going to do is, we are going to go step by step in this particular topic. What are those steps? We will start with the knowledge that you already have as a student of the senior level. What we will assume is that you already know the unitary method. If you don't know the unitary method in mathematics, which you normally do, don't worry, I have a solution for that also. While we are doing the questions, you will find that you will learn that method as well. So let's start with the unitary method. When we say that one student needs 2 apples, there's a question here that one student requires 2 apples during the day. So, how many apples would be required by 2 students? Yes, pretty simple. It will be 4, right? You got that right? Okay. How many apples would be required by 30 students? As simple as that again. Yes, 30 times 2 and you get it 60. Very good. So, this topic becomes easy, very easy if you got these 2 parts correct. Yes, I am going to cheer you up so that you are ready to learn this lesson. Let's start with one question over here. And in that question, we will try to cover as many aspects of this topic as possible. But before I start with the question, have you got your pen and notebook in place? Because this topic is not about me learning stoichiometry, it's about you, right? It's about you enjoying the topic. So, if you don't have already, please pause the video and get a pen and notebook handy so that you can try the questions yourself. Perfect. That's so nice of you. Now, if you've got the pen and notebook, would you like to note down this question? I know some of the students would be able to do it in a jiffy. They would be able to do it orally as well. I wouldn't be surprised. If you are able to do, please practice some more questions based on this topic. But if you need help in this question, please go ahead slowly as we take up the topic. Calcium carbonate limestone reacts with HCl to give us calcium chloride, water and carbon dioxide. In this question, you have to determine the amount of HCl required, moles of water produced, volume of carbon dioxide produced at 0 degrees Celsius and 1 bar pressure when we start with 25 grams of calcium carbonate. There's a D part to the question as well, which I would prefer to take a little later, wherein it says mass of calcium chloride obtained if, that's only if, the calcium carbonate supplied is only 75% pure. So, I will assume that the question that I have written, the 4th part, is to be done in the end. Here we will assume that this 25 grams of calcium carbonate that has been provided to us is the pure form. If you've noted the question, let's go on to solving it. First and the foremost step in solving any question based on chemical equation is to balance the equation. So, please go ahead and balance this equation. Very clear, it will be as simple as that. So, you put a 2HCl. So, we've got equation over here, CaCO3 plus 2HCl gives us CaCl2. Yes, I am taking a very easy equation because I prefer to move from easy to complex so as to make life easier for the students. I have been a student myself and I can understand their woes. Now, next step is you've got to find out the amount of HCl required. How do we find out? We've balanced this equation on the basis of law of conservation of mass, and so the same principle we are going to apply over here. If you notice, this balanced chemical equation is telling me that, see, the coefficient of calcium carbonate is 1, the coefficient of HCl is 2. It is telling me that when we take 1 mole of calcium carbonate, we require 2 moles of HCl, right? If we are starting with 25 grams of calcium carbonate, now 25 grams of calcium carbonate would be how many moles? Go ahead, calculate. Of calcium carbonate is how many moles of calcium carbonate? I will give you the atomic masses. Calcium is 40, carbon is 12, oxygen is 16. Go ahead, calculate. Yes, and how do you calculate the number of moles? Yes, the molar mass comes out, RMM of calcium carbonate comes out as 40 plus 12 plus 48, and that's our 100. That's why I've taken this simple question. So, RMM is 100. So, 25 grams of calcium carbonate would be the mass divided by the RMM. So, it's simple, 1 by 4 moles of calcium carbonate, 25, 25, 4. So, I have here 1/4 mole. So, let's go back to the question. We have 1 mole of calcium carbonate is giving us 2 moles of HCl. So, 1/4 mole of calcium carbonate will give us how many moles of HCl? Can you do the calculation for me? 1/4 will give you how much? Pause the video, do the calculation. You don't want such a simple answer from me, do you? Yes, so 1 mole is 2 moles, 1/4 mole will be double of this, correct. So, 2 into 1 by 4, and that gives you half a mole of HCl. Now, have we answered the question? The question says amount of HCl required. So, if you have the number of moles of HCl, can you find out the amount from this? Yes, again we find out the RMM of HCl, which will be 1 plus 35.5, and that's 36.5. And so, we have mass is equals to number of moles into the RMM, and that gives us, please do the calculations, don't copy. I'm waiting for you to do it. Very good. I like that smile. 2 times 1, 2 times 8, 2 times 2, 2 times 5. What unit will I apply over here? Very good. Grams of HCl. So, the question was amount of HCl required. Now, working on the same principle, if you did this question on your own and you got the answer right, there you go, the first smiley of the lesson. Second part says moles of H2o produced. It's very, very simple. See the question. So, in this question, we should be clear this up and get ready for the second part. Now, for the moles of H2o, what do you have to compare? Calcium carbonate and water. It's a pretty simple question, see. So, calcium carbonate and water. So, according to the equation and according to the data. So, you first write down the values according to the equation. Here the coefficient of calcium carbonate is 1. The coefficient of water is also 1. So, the ratio is 1:1. So, 1 part of calcium carbonate is giving you 1 part of water. So, what is there according to the question? What is the number of moles of calcium carbonate? Yes, let's do this. So, RMM of calcium carbonate, that we've already done, that was 100. Yes. So, number of moles was, very good, it was 1 by 4. Number of moles of CaCO3 is equals to 1 by 4. So 1 by 4 moles of calcium carbonate will give you how many moles of water? Yes, this is what is unitary method I was talking to you about. You don't need to write the full statement, you can just write it as X. Obviously, this question is very simple. So X is equals to 1 by 4 moles of water. Now please remember here, don't get confused between moles and mass. This one is mole, this one is mole. I cannot put grams over here. I cannot say 25 grams of calcium carbonate will give me 25 grams of water. No, we are equating the like values over here, same values. So if you put 25, then you will get 25 grams of water, which will be absolutely wrong because we are comparing over here number of moles. Now, the question was moles of water produced. You got 1 by 4 moles, or better still 0. Go ahead, we can convert it into decimal. Very good, 0.25 moles of water. Now, supposing I asked you to convert this moles of water to mass, that means if I asked you instead mass of water produced, how would you do it? Very good. Mass of water produced would be number of moles, that is 1 by 4 into the RMM of water, that is 18, and the unit would now be grams. Have you got it clear? Now, if you did this question on your own without following what was done over here and you got it right, there goes the second smiley of the lesson. Very good. Let's go on to the third part of this question, and it says you've got to find out the volume of CO2 produced at 0 degrees Celsius and 1 bar pressure. Oh my God, how come we are going to talk about volume? We've only got the mass. How are we going to convert it into volume? Remember, we did the concept of mole, and mole is something which connected us to mass, number of particles and volume. So, if you can recall that concept which I have already taught on the channel, then please go ahead and try the third part of the question yourself. If you are not aware about this connection between mole, mass, volume and number of particles, I would strongly recommend you to watch that video in order to make your concepts clear. Now, in order to do the third part of the question, again we are going to go back to moles only. So, this time we have to connect calcium carbonate and carbon dioxide. See the coefficient here 1, and the coefficient here is also 1, which we have not written. That's the general rule. We don't write 1. Just like in mathematics, you don't write 1x, do you? You just write x. So, when there is no coefficient, it means 1. So, what we've got over here? We've got 1 mole of calcium carbonate and 1 mole of carbon dioxide. So, 1 mole of this is giving us 1 mole of this according to the equation. Now, according to the question, we've already calculated 25 grams of calcium carbonate is equal to 1 by 4 mole of calcium carbonate, right? So, 1 by 4 mole of calcium carbonate will give you how many carbon dioxide? Perfect, 1 by 4 mole. Now, how to convert this mole into volume? Yes, the molar volume, using the concept of molar volume. Now, the conditions that have been provided to you are standard temperature and pressure conditions, 0 degrees Celsius and 1 bar pressure. According to this, it is 22.7 liters. So, if 1 mole of carbon dioxide is taken at STP, it is equals to 22.7 liters at the provided temperature and pressure. So, 1 by 4 mole will be how much? Very good. I know you are finding that this teacher is working so slow, but I have to cater to children who have different learning levels and capacities. So, please bear with me. For 5 calculate it? Oh, why am I giving you the answer? Calculate it yourself. Done? Can you post the answer in the comment section if you've calculated this? And there comes the third smiley of the day, because now you're able to, you've learned three things. You've learned the relation between mole and mass. You have learned the relation between mole and volume. You've also learned the relation between mole and mole. We are now going on to the fourth part of our question, which has asked us to find out the mass of CaCl2 obtained when. So the question was, calculate the mass of CaCl2 obtained if the calcium carbonate, see, sometimes a supplier can give us a defective sample of the calcium carbonate and it is only found to be 75% pure. The mass of calcium carbonate that we started off with was 25 grams. Now, if it is 75% pure, that means the usable, the pure sample of calcium carbonate, pure calcium carbonate in the sample is how much? Yes, 75% of 25 grams. So, it's 75% of 25 grams. See, I am not using any chemistry over here. It's simple plain mathematics. So, calculate and give me the answer. On the basis of this answer, can you answer the remaining part of the question? The mass of CaCl2 obtained if the calcium carbonate supplied is only 75% pure. Now, what mass of calcium carbonate are you going to take in this to calculate CaCl2? Are you going to consider 25 grams or are you going to consider this value? Very good. This value that we get by doing 75% of 25. Now go ahead. I am not giving the answer now. I want you all to calculate. Take your time. Pause the video, please. Please calculate it yourself. Have you got it? It's 18.75 grams of calcium carbonate. Now, 1 mole of calcium carbonate is giving us 1 mole of calcium chloride. How many moles of calcium carbonate? This is according to the equation. This is according to the question. So, number of moles of calcium carbonate now is 18.75 divided by 100. So, how many moles or what will be the mass of calcium chloride formed? So, that is X divided by the RMM of calcium chloride, that is 40 plus 71 because chlorine is 35.5. So, go ahead and do the calculations. Please post your answer in the comments and let me know how the lesson is going. Now, here I have got a very different type of a question. We are taking a big jump over here and we've got a question wherein we have got two equations. Coke requires oxygen for complete combustion, right? And Coke is carbon. Oh yes, not the drinking Coke. Carbon plus oxygen gives you carbon dioxide. Perfect. Oxygen is obtained by decomposition of potassium chlorate. So, that equation also we know, KClO3 gives us KCl plus O2 on thermal decomposition, right? Calculate the amount of KClO3 needed if 5 grams of coke is to be burned. Oh, so I have got here this value provided to me and I have to find out this. Oh, weird question. Something coming from the first equation, and there's another from the second equation. This is my equation 1, this is my equation 2. The second equation is giving me the reactant for the first equation, correct? The question does not ask me to find out how much oxygen is being generated. What it is saying is you just have to find out the amount of KClO3. I will deal with this question in two ways. You can select whatever you are able to relate to. And something interesting, don't worry if you are not able to understand one method. as I said earlier, each one of us have our different learning abilities. Yes, so there is no one one method fits all. It's completely as per your convenience. For those who want to try this question and want to go ahead, here are the atomic masses: potassium 39, chlorine 35.5, oxygen is 16, and of course our favorite carbon is 12, which we know from the unified mass as well. Method 1. What we are going to do is, in method 1, we will solve each equation step by step. So, let's start with it. Now we are starting with the first method. So, KClO3, and in any method, what's the first step that I told you? No, not the relative molecular mass. What's the first step in any stoichiometry question? Not the number of moles, not the mass, not the volume. Very good. You have to balance the equation which is provided to you, or if it is not provided, then you have to write it down. Now my first step is to balance the two equations. So we have a 3 over here, a 2 over here, and a 2 over here. Now we've got the second equation, C plus O2 gives you CO2, correct? This equation is already balanced. We've got 5 grams of coke. So according to the equation, carbon dioxide, 1 mole of carbon giving us, not carbon dioxide, we need to find out the amount of oxygen required, right? So let me do away with the carbon dioxide. Why do I need to bother myself about carbon dioxide? Oxygen. 1 mole of carbon is giving us is combining with 1 mole of oxygen. So 5 grams means how many moles? 5 upon carbon is 12 moles of carbon is there according to this equation. So either you can choose to solve it here, or you can just put a fractional value in this part. So 5 by 12 will give me how many grams of oxygen divided by the RMM, which is 32. So what will be the value of X over here? Please go ahead and calculate. We can also do it in terms of number of moles as well. So if you have 1 mole of carbon, it is requiring 1 mole of oxygen. So 5 by 12 moles of carbon will require how many moles of oxygen? Perfect, 5 by 12 moles. Now let me not worry about calculating the mass, because I am not being asked the amount of oxygen which is being generated. What has been asked of us is what weight of potassium chlorate will generate that oxygen. So let's go to our first equation. Now here you will correlate potassium chlorate and oxygen. So go ahead now and correlate potassium chlorate and oxygen. So how many moles of potassium chlorate? 2 moles of potassium chlorate release 3 moles of oxygen. So how many moles of potassium chlorate will release? How many moles of oxygen do we require for the second equation? 5 by 12 moles. Go ahead and do the calculations, please. So 2 moles of potassium chlorate, 3 moles of oxygen. X moles of potassium chlorate will give us 5 by 12 moles of oxygen, because that is the number of moles of oxygen that we require for the carbon. So this X comes out as this many moles. It's not grams as yet. Are we done with the question? No. Why? Because the question says that we have to find out the amount of KClO3 which is needed, right? So let's get going with that. Okay. How do you convert the the number of moles into mass? Mass is RMM into number of moles. I have done the RMM of potassium chlorate for you, half of it. Please go ahead and calculate yourself. So what we've got over here, RMM of KClO3, if you've got it right, that's another smiley for this lesson. Mass of KClO3, the final, yes, we arrive at it finally, RMM into number of moles. That gives you, yes, where did we get the number of moles from? Yes, we calculated it from this value over here, correct? And we had left it as a fraction for ease of use. We don't do the division at this point. We leave it for the final and we get the answer as 34.02 gram. If you've got this right, so we have a big smiley because you are doing good in this lesson. But remember, we've been talking only about method 1. There is another method to do that. Isn't this a bit long? Would you like to learn something more and we do the two equations together? We bring them up together and do the calculations together. Do we want to learn that? Let's go ahead. This is method number 2 for the question that we've been talking about, potassium chlorate. Now here what we've got is, I'll take the two equations and then derive a third equation from them. KClO3 giving us KCl plus O2. Notice here I've already balanced the equation. Without balancing we don't proceed. That's the first and foremost step, no matter what the method. C plus O2 gives you CO2. Now, the oxygen being produced in the first equation is being used up in the second equation, right? So, 3 oxygen being formed in the first equation means I need to multiply the second equation by 3, or you could also write it as 3 carbon, 3 oxygen, 3 CO2 if you don't want to get confused with this. Now, oxygen produced here is consumed here. Our final products are KCl and 3O2. So, for 2 parts of KClO3, the amount of carbon that can be burnt is 3 parts. So, let's correlate KClO3 and carbon. 2 KClO3 is giving me 3 moles of carbon. Now, the amount of carbon or coke that has been given to us is 5 grams, right? So, first of all, we will convert that grams into number of moles that we have already done earlier. 5 by 12 will give me how many moles of potassium chlorate. Very good. You see, if you notice, we've cut down the steps a lot. First we had calculated here, then we done the potassium chlorate, and then we had gone on to calculate the mass of potassium chlorate. In method number 2, it becomes so easy, correct? So, your X comes out as 10 by 12 into 3. This is the number of moles of potassium chlorate. So, what is the mass of potassium chlorate that you need over here? Very good. It's RMM into the number of moles. And what was the RMM of KClO3 that we had calculated? 122.5. So, we just put that value. If you are doing by this method, you have to show the calculation of RMM. Sorry, I missed out one m over here. So, RMM into number of moles, which is 10 by 36, and our answer, very good, the same as the previous one. Now, what I will be doing is I will be posting a worksheet based on this particular topic on my website, on the Google site. Learning chemistry is easy and fun. Please don't forget to do that worksheet. Are you finding learning chemistry as easy? Perfect. I like that big smile. So don't forget to attempt that worksheet, clear your doubts, and if you can't get the question in one go, don't give up. Try it again till you get it. Don't look out for hand holding every time. Be your own teacher. Stay safe, stay healthy. See you soon in the next video.